Hello class, now we're talking about section 1.3, models and applications. These are basically word problems. The way I approach word problems is that I read the problem over and over again and try and pinpoint the things that the problem is telling me. Now, this takes a lot of practice in order to recognize these buzzwords when they're presented to you. So we're going to work a few problems and I'm going to give examples of how to recognize these buzzwords and pull them out and make them into the equation that will allow you to solve for that variable that's missing here. So in this first problem, when 75% of a number is added to the number, the result is 280. Now, whenever we're dealing with percents, we do not place 75% the exact same way that it's written into the equation. Instead, this is placed into the equation as 0.75 because 0.75 times 100, that gives us the 75%. Now, when 75% of a number, we do not know what this number is that this equation is talking about. So we can put anything up there for a number except for a number, such as a variable. That's the correct thing to put up there. And it can be a letter from A to Z. It can be whatever you want it to be except a number, because it's saying that it does not tell you what this number is. That's for us to figure out. So let's just use n as our number. So when 75% of a number is added, that means we're adding. So that means a plus sign is added to the number. Once again, the same number variable we used there, we need to use it here as well. So n, the result is 280. Result means the answer. So it means that it equals 280. So if we take that and then we write it into an equation, 0.75 n plus n is equal to 280. So now that we have that, 0.75 n plus n, that's more like saying 0.75 n. This is understood to be a 1 right here. So it is 1.75 n is equal to 280. Now, the same as we did in 1.2. But we wanted to get this n over here and get the real number over there, we divide it. 1.75, 1.75. This cancels out. Then we know that our n is equal to 160. And that's our final answer for that problem right there. N is equal to 160. So we're not finished. Let's do another problem here in section 1.3. Once again, I'm going to erase this to give me some more board space. So, the next problem we do, we're going to say a farmer purchased 730 feet of fencing. I spelled fencing wrong, but don't worry about it. To enclose a rectangular garden. To enclose, I'm going to use shorthand here, a rectangular garden. If the length of the garden is 5 feet more than 3 times the width, 5 feet more than 3 times the width, what are the dimensions? What are the dimensions of the garden? Okay, so once again, let's look at what this problem is actually telling us. A farmer, he purchased 730 feet of fencing to enclose a rectangular garden. If the length of the garden is 5 feet more than 3 times the width, what are the dimensions of the garden? So, we know that he purchased 730 feet of fencing. The garden is rectangular in size. The length of the garden is 5 feet more than 3 times the width. What are the dimensions? So, we know that this right here is his garden. He purchased 730 feet of fencing. So, he purchased 730 feet of fencing to go around this garden here. This is the length of the garden. This is the width. It's telling us that the length of the garden is 5 feet more than, so that's plus, 3 times the width. What is the width? We don't know that. So for the width, let's just say x, because you know this is 5 feet more than 3 times that width. So now that we have that, the equation for the perimeter of a rectangle is S is equal, S, is it S or P? It's P, I'm sorry. I said perimeter, I should have picked up on it. P is equal to 2 lengths plus 2 widths. Because we have 2 sides right here, 2 sides right there. So our P is 730. 2, 5 plus 3x plus 2 times x. Once we distribute all that, that is 730 is equal to 10 plus 6x plus 2x. Then we do some simplifying because over here we see that we have 6x and 2x. And that is going to equal to 8x. So this is 730 is equal to 10 plus 8x. Now we can subtract 10 from both sides. Then we have 720 is equal to 8x. If we divide both sides by 8, what do we have? This cancels out. So x would be equal to 90. But we're not finished because we know what this is equal to. This side right here is equal to 90. Now that we know x, and we say that the width, I'm going to write in black now. We said that width is equal to 90 feet. What about the length here? Well, do the same thing. Now that we know what x is, just substitute it in right here. So it's 5 plus 3 times 90 equals 5 plus 3 times 90 is 270. 270 plus 5, that's 275. So our length is 275. So our L here is 275 feet. So, what are the dimensions of the garden? 90 feet is the width. The length is 275 feet. And that is it for that equation there. All right. We have one more problem I'm going to do in this section here. Okay, this next problem is solve for the specified variable. Solve for specified variable. All right, so for this one, we have S is equal to pi R1 plus R2 L. It wants you to solve for R2. All right, so we have to solve for R2. We cannot break both of these up and just pull R2 out because they're together. So what I recommend is rewriting this equation to say S is equal to pi L R1 plus R2. All I did was I brought the L over here. That's all. And perfectly fine, I can do that because pi is saying pi times R1 plus R2 times L. So if I put it over here, all I'm saying is pi times L times R1 plus R2. So it's basically saying the same exact thing, multiplying everything. Now what I'm going to do, I'm going to take this pi RL, and I'm going to, this pi L, not RL, pi L, and distribute it throughout this parenthesis here. So this will be S is equal to pi L R1 plus pi L R2. Now that I have that, I'm still trying to solve for R2. I'm going to push this pi L R1. I'm going to place it over here. Once again, in order to do that, I have to subtract it. So pi L R1 pi L R1. So now what I have, this cancels out. So I have S minus pi L R1 is equal to pi L R2. Now if I want to get pi L R2 all by itself, all I have to do is divide by pi L. Once I do that, this cancels out. I have R2 is equal to S minus pi L R1 all divided by pi L. This is our final answer. Now some people would like to take this and break it out and say S over pi L minus pi L R1 over pi L. Knowing that the pi L's are going to cancel, then you just have R1 S over pi L minus R1 is equal to R2. You can perfectly do that. However, the book wants you to stop right here. You're perfectly fine stopping right there. You do not need to go any further. So I would not recommend going this further right here. When you, right there, it's done. It's over. So I'm just going to erase this right here and say stick with this. Now, you just cannot say you're just going to cancel this out and cancel that out right there because they are together as a set. Both of them share that minus sign. But what you can do, simply because if you did that, look at this. If you said S minus pi L R1 and then pi L, and you cancel this out, then you're saying your answer is S minus R1 is equal to R2. That is absolutely wrong. That's why I recommend once you get to this part right there, stop. The problem is done. You don't have to go any further. All right. And that concludes section 1.3, Models and Applications.